Okay, guys. So today we are going to start with the next part of the organic chemistry. कल हम लोग फिनोल कर रहे थे. फिनोल में हम लोगों ने रिएक्शंस ऑफ फिनोल विद रिस्पेक्ट टू बेंजीन ग्रुप कर लिए थे. अब पेपर में एक और क्वेश्चन जो है वो अक्सर आ जाता है मेरे बच्चों कि वो क्वेश्चन पूछता है कि व्हाई फिनोल is stronger acid than ethanol. Okay, so in the papers, normally they are going to ask you this question that why phenol is stronger acid than ethanol. Okay, so last time you know that we had arranged different acids according to their strength. Okay, mineral acid was the strongest one, and then carboxylic acid, then phenol, then water, and then alcohol. Okay, so you got all these things. Okay, so now the next question: why phenol is stronger acid than ethanol? Okay, so my dear, have a look up here in the phenol. This is the phenol. This is phenol group. This is OH group. Okay, so in the phenol, this chain, okay, that is actually the benzene group. And this benzene up here, that is C6H5. Why? Because you know that I told you benzene do the substitution reaction. So the place where any group is being attached, from that place the hydrogen that is being substituted. Okay, so there is no hydrogen present up here. Okay, so if the benzene write it like that. If the benzene is attached with the OH group and benzene is C2, sorry, benzene is C6H5O and H. Okay. On the this is the first thing, phenol. Now come towards the ethanol. Ethanol. In ethanol, my dear, you got C2H5OH. So this group that is called as the alkyl group. Okay, so this is the alkyl group and it is attached with the O and H group. Now everybody just listen carefully. Why phenol is stronger acid than ethanol and why ethanol is weaker acid than phenol. Okay, if you look up here, benzene, always keep remember we use the word for it. It's the electron withdrawing group. Withdrawing group. Electron withdrawing group mean, my dear, any element attached with the benzene having lone pair. So the lone pair are delocalized to the benzene ring. You know that. So benzene is considered to be the electron withdrawing group. So benzene withdraw the electron from the oxygen. Okay. So oxygen and hydrogen, you know that that is already polar. Okay. So when benzene withdraw the electron towards itself, the polarity that would increase. And when the polarity increases, automatically the bond would become weaker. Okay, and when the bond would become weaker, automatically when you dissolve it in water, it produces more H positive ions. So that is why it is stronger acid. Now, if you consider the ethanol, in ethanol, the alkyl group is considered to be the electron donating group. Donating, or the word is used repelling group. So electron donating or electron repelling group. Okay. So this one is going to repel the electron towards oxygen. So oxygen and hydrogen, that is polar. But when alkyl group gives the electron to oxygen, oxygen sends the electron towards the hydrogen little bit more time. So the polarity that would decrease. When the polarity decrease, automatically bond becomes strong. And strong bond normally, my dear, they are not broken down when added in the water. So that is why it's a weak acid. Did you get it? Muskan and Yahya?
Yes, sir.
Okay. So just write it down. Phenol is stronger acid than phenol is stronger acid than ethanol, as in phenol benzene group is an electron withdrawing group due to which the polarity of OH bond increases, resulting in the weakening of OH bond. So more H positive are produced when dissolved in water. Okay. Now, my dear, write down the second point for ethanol. In ethanol, the alkyl group is an electron donating group, due to which polarity of OH bond polarity of OH bond decreases, resulting in of OH bond to be increased. So less H positive ions are produced when dissolved in water. Okay. So most of the time he's going to ask you these kind of the question that why phenol is a stronger acid, okay, than ethanol, and the reason I told you, phenol has got benzene group, which is electron withdrawing group, making the OH bond more polar, due to which the OH bond would become weak and producing more H positive ion. Whereas alkyl, it repels the electron, it donates the electron towards the oxygen. So when oxygen gains the electron, it considered itself to be very, you can say that I got too much electrons. Okay, so it sends the electron towards the hydrogen. So the polarity of OH bond that would decrease and the strength of OH bond would increase, resulting in less hydrogen ions to be produced, so causing less acidity. Did you get it? Can I wrap this one, guys? Okay, my dear students. Now we are going to do a last thing. Have a look up here. I'm going to draw an acid up here, C double bond O and O and H. Okay. Now I'm going to draw another acid up here, but this acid got the chlorine on one side. You should draw this one. Carbon, hydrogen, hydrogen, hydrogen. Okay. And then you got C double bond O and OH. So this one got two chlorine. Okay. And then C double bond O and OH. And this one got the three chlorine like that. Okay, my dear students, if you look at these four compounds, all of them they are acid. This is the ethanoic acid. It is having the pH 3. Okay. This one, if you look the chlorine, that is also electron withdrawing group. It withdraw the electron, so the OH bond polarity that would increase, so the pH that would decrease to 2.5. So it would become a little bit more acidic. Now, if you got the two chlorine attracts, they are more electron withdrawing. Okay, so the polarity of this OH bond would increase too much, making this bond more weaker. So the pH that would become 1.5. And up here you got the three chlorine. So three chlorine will attract the electrons. So this one partial positive, this one partial negative. So this one pH that would be 1. Okay. So now, my dear students, you should know the pH that when you are going to add the chlorine atom. So chlorine atom, they are electron withdrawing group, due to which the OH polarity that is going to increase, and automatically you can see the strength of the acid that is going to increase, having the low pH. Okay. So this chapter of phenol that has been finished. Okay. Now we are going to start with its past paper question. So all of you please come close. Okay, my dear. So let's start with this one. Now listen it very carefully. ये देखने में लग रहा है कि बहुत मुश्किल क्वेश्चन है. The complex structure is being made, but the method of solving this one, that is very simple. Okay. Now the first thing is saying you complete the following table about the reactions of this one whole thing with three reagents. First of all, sodium. Sodium is a metal, so metal would react with the water, with alcohol, and with phenol, and with carboxylic acid. Okay, so it means it could react with the phenol and carboxylic acid. So if you look up here, this is the phenolic group. So it means sodium can react with it. So when it will react with it, the hydrogen would come out in the form of hydrogen gas, and here you got minus and Na positive. So you should draw this whole structure up here. Okay, have a look up here. This is benzene, and then you got this one C double bond O, and this is again benzene. This is again benzene, and this one O minus Na positive. Okay, and what type of reaction is this? So if you look, sodium firstly it was 0. When it's joined up here, it is +1. So this is actually the redox reaction, my dear. Redox reaction you can say, or this is the neutralization reaction, not the neutralization one. Yeah, redox reaction is okay. कार्बोक्सिलिक एसिड है कितने भाई इसमें दिखा दें. सी के साथ OH है भाई, क्या हो गया. Okay, now move towards the next question, guys. The next question is saying excess of aqueous bromine. Aqueous bromine. So I told you कि phenol जो है उसकी reactivity increase कर गई भी है. So without catalyst it can react with the bromine. And if you got the aqueous bromine, the three positions should have the bromine. Okay. So this is the phenolic group. Okay. So on position 2, bromine. Position 4, bromine. and position 6 is already occupied. Okay, so you don't need to mention it. So it means these two positions would be occupied, and you know that when anything reacts with the benzene, so that reaction is called as the electrophilic substitution. Okay, so you should draw this one up here, excess of aqueous chlorine. So you should draw the structure like that. This is benzene. Okay, C double bond O, O. This is the second benzene. Okay, and here OH is attached. So on position 2 bromine is present, and 2, 4, sorry, 1, 2, 3, 4. So 4 position bromine is present. So position 6 is occupied, and this reaction that is called as the electrophilic substitution. Okay, so this is electrophilic substitution. The next thing we are going to start up here, so you just have to listen this thing carefully, please. Everybody just listen. Here, excess of hot NaOH. Okay, so I'm telling you first of all about the NaOH. Okay, so what is the NaOH? NaOH, if it is present, if you got the cold NaOH, the cold NaOH, okay, it acts as base only. Okay, it acts on only as a base. Whereas if you got the hot NaOH, so hot NaOH it acts as base, but as well as it do the process of acidic hydrolysis. Acidic hydrolysis means that the ester linkage that would be broken down, or the amide linkage that would be broken down. Okay, nitrile could be hydrolyzed. So acidic hydrolysis. Okay. So now, my dear students, if you look in the question, he said hot NaOH. So hot NaOH do the process of the acidic hydrolysis. So first of all, we do the process of hydrolysis. In the hydrolysis, what would happen? This ester linkage would be broken down. Okay, so you got the NaOH, the ONA that would be attached with C double bond O, and H would be attached with this one. Okay, so you will get the two different products. So I'm going to make those two products. So the first product is benzene. Okay, and we got OH up here. Step by step, I'm doing all these things. Don't you worry. And this one, C double bond O, and with that we got O minus Na positive. So this thing would be formed, and this thing. So make it benzene, and with this benzene, the OH is attached like that. Okay. So this one would break down. The second thing, it act as a base. So base react with the acid. Phenol is a acid. So this is the phenolic group, my dear. Okay. So this phenolic group that would react with the NaOH. So you will get O minus Na positive, and you will get this one O minus and Na positive. Why? Because this is also the phenol, and this was also the phenol. Did you get it? Okay, now keep remember, my dear students, hydrolysis जो होती है उसमें ये linkage break कर जाती है. If you got the acidic hydrolysis में water use होता है, और OH single bond O के साथ लगती है और HO के साथ लगती है acidic hydrolysis में. But if you got the basic hydrolysis NaOH, so ONA that would attach up here and H would attach up here, so this bond will break down. Okay, तरीका पता चल गया? So what would be the product up here? If we draw the two products, so the first product would be, my dear, that benzene. This is C double bond O and O minus Na positive, and here we got O minus and Na positive. And the second thing, that is O minus and Na positive, and this reaction is actually the neutralization reaction, because acid and base they are reacting. Phenol is an acid, NaOH is a base. So neutralization reaction, and the second reaction in it, that is the acidic hydrolysis. Okay, everyone got it, guys? Oh, sorry, basic hydrolysis. I'm sorry, basic hydrolysis. I Okay, guys. So for this one, we should do this one. Okay. So first of all, you should react the above cyclohexanol and phenol. Both of the compounds are present up here. See, this is cyclohexanol and this is phenol. So the first reaction you have to do, that is with sodium. याद है बताओ, साइक्लोहेक्सानोल सोडियम के साथ रिएक्ट कर जाएगा? भाई मैंने लास्ट टाइम भी बताया था कि मेटल वुड रिएक्ट विद द अल्कोहल, फिनोल एंड कार्बोक्सिलिक एसिड सबके साथ। तो ये अल्कोहल है खुदा के बंदे, तो सोडियम जो है, सोडियम इसके साथ रिएक्ट कर जाएगा और ये O माइनस Na पॉजिटिव बन जाएगा, और फिनोल के साथ भी कर जाएगा तो O माइनस और Na पॉजिटिव बन जाएगा, और ये आपके जो है वो इसकी दो प्रोडक्ट्स बन जाएंगे। ठीक है जी, ये सोडियम के साथ हो रहा है, ये फर्स्ट रिएक्शन में दोनों के साथ रिएक्ट कर जाएंगे और आपकी प्रोडक्ट ये बनेगी। इट इज अनेबल टू रिएक्ट विद द अल्कोहल, ये अल्कोहल है तो इसके साथ नो रिएक्शन। जबकि फिनोल के साथ जो है वो मेटल, मेटल ऑक्साइड और मेटल हाइड्रोक्साइड रिएक्ट कर जाते हैं, तो ये रिएक्ट कर जाएगा फिनोल और ये क्या बन जाएगा, वही O माइनस Na पॉजिटिव। अब याद आ गया, इसीलिए मैंने कहा था कि ये टेबल देखने में बहुत सिंपल है सर, लेकिन बेटा इसको यूज करना जो है वो असल काम है। पता चल गया ना, ये चीज जहन में रखो यार, अल्कोहल कुड ओनली रिएक्ट विद द मेटल सोडियम। ठीक है, यानी किसी मेटल के साथ कर सकती है, वेयर एज द अदर थिंग्स दे कुड रिएक्ट विद द मेटल, मेटल ऑक्साइड, मेटल हाइड्रोक्साइड, विद द फिनोल और कार्बोक्सिलिक एसिड, चारों के साथ कर सकते हैं। ओके साथ, दैट्स योर टर्न माय बॉय। ब्रोमीन, ब्रोमीन इन दोनों में से किसके साथ करेगी? इसके साथ करेगी, साइक्लोहेक्सानोल के साथ? नहीं, बिल्कुल नहीं करेगी जी। ठीक है, जबकि ब्रोमीन है फिनोल के साथ कर जाएगी, क्योंकि एक्वस ब्रोमीन है तो इसकी 3 पोजीशंस के ऊपर ब्रोमीन जो है वो दैट वुड बी अटैच्ड फॉर्मिंग द व्हाइट प्रेसिपिटेट, एंड दिस इज इलेक्ट्रोफिलिक सब्स्टिट्यूशन। जी, अल्कोहल के साथ ब्रोमीन का कोई रिएक्शन आज तक आपने देखा है जिंदगी में? तो फिर ब्रोमियम ब्रोमीन है ना मारा नहीं, वो होता भी होगा, होता ही नहीं है। अगला जी, आयोडीन प्लस OH माइनस, सो दिस इज एक्चुअली द ट्राइआयोडोमीथेन टेस्ट। तो दोनों के अंदर देख लें कोई ऐसा ग्रुप मौजूद नहीं है। ये देखें यहाँ पे ये C, ये H और इसकी साइडों पे CH2 लगे हुए हैं, तो आपको जो है वो CH3 के साथ C डबल बॉन्ड O होना चाहिए, यहाँ तो एल्डिहाइड और कीटोन में, यहाँ CH3 के साथ COH और H होना चाहिए अल्कोहल में। तो भाई इसके ऊपर भी नहीं लगेगा और इसके ऊपर तो वैसे नहीं लगेगा, क्योंकि CH3 के साथ C डबल बॉन्ड वो है ही नहीं, तो दोनों के ऊपर जो है वो अप्लाई नहीं होगा ट्राइआयोडोमीथेन। I2 एंड OH माइनस विल शो दिस वन। अगली चीज देखें, एन एक्सेस ऑफ एसिडिफाइड पोटेशियम डाइक्रोमेट। तो ऑक्सीडेशन, ऑक्सीडेशन अल्कोहल्स की होती है, तो साइक्लोहेक्सानोल की हो जाएगी। ये कौन सी है, ये कौन सी अल्कोहल है? ये कार्बन है, इसके साथ एक H है, दिस इज द सेकेंडरी अल्कोहल। तो यहां से ये OH और H मिलके वाटर बन जाएगा, और वो जो ऑक्सीडाइजिंग एजेंट है वो क्या करेगा, उसकी ऑक्सीजन आके इसके साथ लग जाएगी लाइक दैट, ये C डबल बॉन्ड O ये बन जाएगा। जबकि फिनोल के साथ जो है वो रिएक्शन नहीं करेगा पोटेशियम डाइक्रोमेट। डिड यू गेट इट? दोनों तरफ सी, किस कौन सी चीज अल्कोहल है? साइक्लोहेक्सानोल इज अल्कोहल, तो मैं अल्कोहल ही कह रहा हूं भाई, दोनों तरफ कार्बन है, एक H है, तो ये सेकेंडरी अल्कोहल है ना, तो कीटोन बन जाएगा।